Hello dear students, in this video I'll solve the questions for the sample paper CBSE Class 12 Applied Mathematics subject code 241 for term 2. We will see the general instructions. The time allowed is 2 hours, maximum marks is 40. The question paper is divided into 3 sections A, B and C. In section A there are 6 questions each carrying 2 marks and internal choice is given for 2 questions in section A. And then section B has 4 questions of 3 marks each and internal choice is given for 1 question. Section C has 4 questions. It contains 1 case-based question and internal choice is provided in 1 question. Moving on to the first question of section A. The marginal revenue function for a commodity is given by marginal revenue equal to 9 plus 2x minus 6x square. Find the demand function. So this is from the unit calculus under the heading application of integrals or integration and its applications. So here the marginal revenue is given. We need to find the demand function. So here given marginal revenue equal to 9 plus 2x minus 6x square. Now to find the demand function we need to find P in terms of x. So to find P, let us find the total revenue from the marginal revenue function. So total revenue equal to integral marginal revenue function into dx. So it is integral 9 plus 2x minus 6x square dx. So this is equal to 9x plus 2x square by 2 minus 6x cube by 3 plus the constant of integration k. So this is equal to 9x plus x square minus 2x cube plus k. So this is the total revenue function. Now we know when the level of output is 0, total revenue is 0. So this implies k is equal to 0. Therefore, total revenue equal to 9x plus x square minus 2x cube. Now we know total revenue is equal to price per unit into the level of output. So 1 implies Px is equal to 9x plus x square minus 2x cube. This implies P equal to 9 plus x minus 2x square. So this is the demand function, which is the demand function. So here up to finding the total revenue it carries 1 mark and finally finding the demand function it carries 1 mark. So this question is for 2 marks. Moving on to the next. The first question has internal choice. The R part of the first question is the marginal cost of producing X pairs of tennis shoes is given by marginal cost is equal to 50 plus 300 upon X plus 1. If the fixed cost is rupees 2000, find the total cost function. So here marginal cost is given. We need to find the total cost function. Given marginal cost is 50 plus 300 by x plus 1. So total cost is equal to integral marginal cost. So total cost is equal to 50 plus 300 by x plus 1 into dx. So this is equal to 50x plus 300 integral dx by x plus 1 is log mod x plus 1 then plus k, which is the constant of integration. Now If x is equal to 0, we have the total cost is rupees 2000, because here it is given the fixed cost is rupees 2000. So when the level of output is 0, the total cost will be 2000. So this implies 2000 is equal to 50 into 0 plus 300 into log 0 plus 1 is 1 plus k. So which means we have k is equal to 2000. So here up to finding this total cost, it carries 1 mark, and finally finding the last step, that is the total cost function, this carries 1 mark. So total cost equal to 50x plus 300 into log of x plus 1 plus 2000. So the final step carries 1 mark. Next question. Find the present value of perpetuity of rupees 600 at end of each quarter if money is worth 8% compounded quarterly. So we have to find the present value of perpetuity of rupees 600. So the periodic payment is rupees 600, and at the end of each quarter, if money is worth 8% compounded quarterly. So here given R is equal to rupees 600 and I is equal to, here 8% is compounded quarterly. So I will be 0.08 upon 4. So it is 0.02, where I is the rate per period. So the present value of perpetuity P, it is given by R by I. So R is 600 and I is 0.02. So this is equal to 30,000. Therefore, the present value of perpetuity is rupees 30,000. So here writing what is given and finding I carries 1 mark and the final answer 1 mark. Moving on to the next question. What effective rate is equivalent to a nominal rate of 8% per annum compounded quarterly? So here we need to find the effective rate. Nominal rate is given, and it is also given it is compounded quarterly. So first let us write what is given. Nominal rate is given, which is 8%, so 0.08, and the number of conversion periods per year, it is nothing but it is 4, because it is compounded quarterly. So effective rate is given by 1 plus R by M, the whole raised to M minus 1. So it is 1 plus 0.08 by 4, the whole raised to 4 minus 1. So it is 1 plus 0.02 the whole raised to 4. It is 1.02 the whole raised to 4 minus 1. 1.02 the whole raised to 4 is 1.0824 minus 1. So it is 0.0824. So the effective rate is 0.0824. It is nothing but 8.24%. So for writing the formula 1 mark and the final answer 1 mark. The third question has an internal choice. So the R part is find the present value of an annuity of rupees 1000 payable at the end of each year for 5 years if money is worth 6% compounded annually. So here we need to find the present value of annuity of rupees 1000. So given R is equal to rupees 1000, it is payable at the end of each year. So it is ordinary annuity and the time period is 5 years. So the number of periods is 5 if money is worth 6% compounded annually. So here compounding is also done annually. So I is 6%, which is 0.06. So this is nothing but present value of ordinary annuity. The present value of ordinary annuity is given by R into 1 minus 1 plus I the whole raised to minus n upon I. So this is very easy. We just have to substitute the values. And here 1 plus I the whole raised to minus n will be 1.06 the whole raised to minus 5. The value is given directly here. So it is 1 minus 1 plus 0.06 the whole raised to minus 5 upon 0.06. So this is equal to 1000 into here 1.06 the whole raised to minus 5 is 0.7473 upon 0.06. So this is equal to 0.2527 upon 0.06. So this when we simplify, we get it as 4211.67 rupees. So the present value of the annuity of rupees 1000 payable at the end of each year for 5 years when money is worth 6% compounded annually is rupees 4211.67. Here again formula carries 1 mark and the final answer 1 mark. A sampling distribution of the sample means X bar is formed from a population with mean weight mu equal to 60 kg and standard deviation sigma equal to 9 kg. What is the expected value and standard deviation of X bar if the sample size is 36? So here it is given a sampling distribution of the sampling means is formed from a population whose mean weight is 60 kg and standard deviation is 9 kg. We need to find the expected value of X bar and standard deviation of X bar if the sample size is 36. Now this we have discussed about sampling distribution or standard error of sampling distribution. In that we have this. So here the expected value of X bar, it is nothing but expectation of X bar. This is what we have to find. So this expectation of X bar is nothing but it is equal to mu. So the expected value of X bar is equal to 60 kg. And then we have to find the standard deviation of X bar. The standard deviation of X bar is nothing but it is the standard error of X bar. Standard deviation of X bar is the standard error of X bar. This is nothing but this is equal to sigma by root 10. So this is sigma is 9 kg and n is 36. So this is equal to 9 by 6 which is 1.5 kg. So for finding the expected value of X bar 1 mark and for finding the standard deviation of X bar it is 1 mark. So a total of 2 marks. Next question. Find the trend values using 3 yearly moving average for the loans sanctioned to farmers by a particular branch of a bank in a village. So for various years 2016, 17, 18, 19, 20 and 21, the amount of loan sanctioned in lakh rupees is given. 25, 30, 32, 40, 45, 50. So we need to find the 3 yearly moving average. So let us draw this table. So for various years, the amount in rupees lakhs, let us write it here. Then in the next column, we have 3 yearly moving total and in the next column, 3 yearly moving average. So the 3 yearly moving total, leave the first year, then for 2017 it will be the sum of the amount in these 3 years. So these 3 years add up to 87, then For 2018, the 3 yearly moving total is 30 plus 32 plus 40. So this is equal to 102. Then for 2019, the 3 yearly moving total is 32 plus 40 plus 45. So it is 117. Then for 2020, the 3 yearly moving total is 40 plus 45 plus 50. It is 135. Now the 3 yearly moving average is the average of these three. So the average of these three can be found by dividing the 3 yearly moving total by 3. So for 2017, the 3 yearly moving average is 87 by 3, which is 29. Then we have 102 by 3, which is 34. Then 117 by 3, 39. Then 135 by 3, 45. So these are the 3 yearly moving average for the given data. Finding 3 yearly moving total carries 1 mark and finding 3 yearly moving average carries 1 mark. Next question. The feasible region of the linear programming problem, minimize z is equal to 3x plus 2y, subject to constraints 2x plus y greater than or equal to 6, x minus y greater than or equal to 0, x greater than or equal to 0, y greater than or equal to 0 is given below. So here this is the graph and this is the line 2x plus y greater than or equal to 6. Equal to 6, and the region corresponding to this is, it is this part, the arrow mark is shown here, and x minus y greater than or equal to 0, it is, the line is x minus y equal to 0, this is the line, and the region corresponding to x minus y greater than or equal to 0 is this part. So and x greater than or equal to 0, y greater than or equal to 0 are the non-negative constraints. So the feasible region is the shaded region. We need to determine the optimal solution and justify your answer. So here we can see that the region is unbounded. Here the feasible region is unbounded. So first we have to find the minimum value of z from the corner points, and then we have to proceed. So we have the corner points as P2, 2 and Q3, 0. P2, 2 and Q3, 0. So for P2, 2, for this corner point, we have Z is 3 into 2 plus 2 into 2, which is 10. And for this corner point Q3, 0, the value of Z is 3 into 3 plus 2 into 0, which is 9. So this is the minimum value. Now since here the feasible region is unbounded, we have to check for the inequality 3x plus 2y less than 9. So first we have to draw the line 3x plus 2y equal to 9, and then we have to see whether this inequality, if it crosses the feasible region or not. So if we draw this line 3x plus 2y equal to 9, so this is the line 3x plus 2y equal to 9. Here this line does not cross the feasible region, but it just passes through the corner point Q3, 0. So we have the smallest value of z is 9. Since the feasible region is unbounded, we draw the graph 3x plus 2y less than 9. As the inequality 3x plus 2y less than 9 passes through the corner point Q3, 0 without interfering the feasible region, this corner point Q3, 0, it minimizes z, and minimum value of z is equal to 9. Therefore, the optimal solution is x equal to 3 and y equal to 0. So this is the optimal solution. In the question it is asked to find the minimum value of Z and we have to justify the answer. So finding this, drawing this table and finding the minimum value carries 1 mark and justifying the answer carries 1 mark. Next question. Coming to section B, the 7th question, the supply function for a commodity is given by P equal to 6x square plus 4x plus 3, where x is the quantity supplied at the price P. Find the producer's surplus when the price of the commodity is rupees 48. So this question is from application of integrals under the heading consumer surplus and producer surplus. So this is a question on producer surplus. It is a direct question. We just have to use the formula and find the answer. So here the supply function is given where x is the quantity supplied and P is the price per unit. We need to find the producer surplus when the price of the commodity is rupees 48. So given P naught is equal to rupees 48. Now we need to find x naught by substituting P naught as rupees 48 in the given supply function. So substituting P naught equal to 48 in P equal to x square plus 4x plus 3 implies 48 equal to x square plus 4x plus 3. So this implies x square plus 4x minus 45 equal to 0. So this is a quadratic equation in x. We can solve this equation. We get x plus 9 into x minus 5 equal to 0. This implies x is equal to 5. Since we cannot have x is equal to minus 9 because x is the level of output or the quantity supplied, now this cannot be negative. Since x greater than 0. Greater than or equal to 0. Okay. Therefore, x naught is equal to 5. So we got P naught is given and we have found x naught. Now we can find the producer surplus. It is given by P naught x naught minus integral 0 to x naught, the supply function into dx. So this is equal to 48 into 5 minus integral 0 to 5. The supply function is x square plus 4x plus 3 dx. So this is equal to 240 minus, if we integrate we get x cube by 3 plus 4x square by 2 plus 3x. 0 to 5. So this is equal to 240 minus 125 by 3 plus 5 square into 2 is 50 plus 15, and the lower limit if we substitute we will get 0. So this when we simplify we get this as 133.33. Therefore the producer surplus is rupees 133.33. So here finding x naught carries 1 mark, then writing the formula for producer surplus 1 mark and the final answer 1 mark. Next question, the following table shows the quarterly sales in crore rupees of real estate company. Compute the trend by, I think this should be 4 quarterly moving averages. So the quarters are given for the years 2018, 19, 20. The quarterly sales in crores of rupees. It is given in this table. We need to find the 4 quarterly moving averages. So for the years, so let us draw this table. So for 2018, 2019 and 2020, the data which is given here, you can write it in this way. And then moving on to next year 2020, first quarter 27, second quarter 24, third quarter 30 and fourth quarter 36. Now first let us find the 4 quarterly moving total, then 4 quarterly moving average and then 4 quarterly centered average. So the 4 quarterly moving total, it will come in between the second quarter and third quarter of 2018. So we have to add these 4 and write it somewhere here. So 12 plus 14 plus 18 plus 20, this is 64. And then for the next quarterly moving total, we have to add these 4. When we add, we get 14 plus 18 plus 20 plus 18, we get 70. Then the next 4, 18 plus 20 plus 18 plus 16, so we get 72. Then the next 4, 20 plus 18 plus 16 plus 20, 74. Then the next 4, 18 plus 16 plus 20 plus 22, 76. Then 16 plus 20 plus 22 plus 27, 85. Then the next 4, 20 plus 22 plus 27 plus 24, it is 93. Then the next 4, 22 plus 27 plus 24 plus 30, it is 103. And the last 4, 27 plus 24 plus 30 plus 36 is 117. So we have found the 4 quarterly moving total. Now coming to 4 quarterly moving average. So it is 4 quarterly moving total divided by 4. So 64 by 4. This is 16. Then 4 quarterly moving average, the next 4 quarterly moving average will be 70 by 4. So it is 17.5. Then 72 by 4, 18. Then 74 by 4, 18.5. 76 by 4, 19. Then 85 by 4, 21.25. Then 93 by 4, 23.25. Then 103 by 4, 25.75. And 117 by 4 is 29.25. Now these 4 quarterly moving averages, it is obtained between these 2 quarters, quarter 2 and quarter 3. Then this is obtained between Q3 and Q4. So what we do is we find 4 quarterly centered average. This is the average of these 2. So that we will get the trend value for the third quarter of 2013 directly. So here the average of 16 and 17.5 is 16 plus 17.5 by 2. So 23.5 by 2, it is 16.75. Then we have average of these 2, 17.5 and 18. So 17.5 plus 18, the whole thing divided by 2. It is 17.75. Then the average of 18.18 and 18.5, it is 18.25. Then the average of 18.5 and 19, it is 18.75. Then the average of 19 and 21.25, so it is 20.125. Then the average of 21.25 and 23.25, so it is 44.5, so it is 22.25. 44.5 divided by 2, which is 22.25. Then 23.25 and 25.75, the average of these 2. It is 24.5. and finally average of 25.75 and 29.25. So the average is 27.5. So these are the 4 quarterly centered average. Now finding the values in this column, 4 quarterly moving total, it carries 1.5 marks, and finding the final answer, 4 quarterly centered average. Finding these values carries 1.5 marks. So this is from Unit 4, which is index numbers and time-based data. Index numbers was already completed in the first term. So for the second term, we have time-based data. So this is question from time series analysis. Moving on to the R part of the same question. Fit a straight line trend by the method of least square and estimate the trend for the year 2023. So for year 2014, 15, 16, 17, 18, 19 and 20, the sales in lakhs is given. We need to fit a straight line trend by the method of least square. Again, this question is also from time series analysis or trend analysis. So let us draw a table like this. Whatever is given in the question is written here. We have year and the required y values are written here. So let us take x is equal to year minus, here the number of years is 2, 4, 6, 7. So the number of years is odd. So we can take the origin as the year in the middle. So it is year minus 2017. So here we will have 2014 minus 2017 minus 3, then 2015 minus 2017 minus 2, then 2016 minus 2017 minus 1, 2017 minus 2017 0, 2018 minus 2017 is 1, 19 minus 17 2, 20 minus 17 3. The next column we have x square and then we have xy. So here we have x square and xy. So x square will be minus 3 the whole square 9, then minus 2 the whole square 4, minus 1 the whole square 1, 0, 1 square 1, 2 square 4 and 3 square 9. So as a result we have summation x square, it is equal to 28. And then now we have to find xy. Xy will be 26 into minus 3 minus 78, 26 into minus 2 minus 52, 44 into minus 1 minus 44, 42 into 0, 0, 108 into 1, 108, then 120 into 2, 240, then 166 into 3, 498. Now if we find the summation xy, so it will be minus 78 minus 52 minus 44 plus 108 plus 240 plus 498. So it comes out to be 672. And here summation y is, when we add all these, we get 532. Now we have to find the trend line. So A is summation y by n. Summation y is 532 and n is 7. So this is equal to 76. And B is summation xy upon summation x square. So it is 672 upon 28. This is equal to 24. So yt is equal to a plus bx. So the trend line is yt is equal to 76 plus 24 into x. Now we need to estimate the sales for the year 2023. Therefore, estimated sales for 2023 equal to yt equal to 76 plus 24 into, here we got y is equal to 76 plus 24 x. Now this x is nothing but it is year minus 2017. So it is year minus 2017. So we need to estimate the sales for 2023. So this will be 76 plus 24 into 2023 minus 2017. So this will be 76 plus 24 into 6. So this is equal to 220. So the estimated sales is rupees 220 lakhs. Moving on to the next question. A machine produces washers of thickness 0.5 mm. To determine whether the machine is in proper working order, a sample of 10 washers is chosen, for which the mean thickness is 0.53 mm and standard deviation is 0.03 mm. Test the hypothesis at 5% level of significance that the machine is working in proper order. So here it is given a machine produces washers of thickness 0.5 mm. So this is the population mean mu. To determine whether the machine is working in proper order, a sample of 10 washers is drawn. So the sample size is given, it is 10, for which the mean thickness is 0.53 mm. So here this is the sample mean x bar and the standard deviation is 0.03 mm. So the sample standard deviation is 0.03. We need to test the hypothesis at 5% level of significance whether the machine is working in proper order. Given T 0.025 equal to 2.262 at nu is nothing but it is the degrees of freedom at nu equal to 9. Here the sample size is 10. So the degrees of freedom will be 10 minus 1 which is 9. So this is the tabulated value which is given here. So this is hypothesis testing using t-test. So it is from the unit Inferential Statistics. Now let us solve this question. So the first step is define null hypothesis H0 and alternate hypothesis H1 as follows. So the null hypothesis H0 is mu equal to 0.5 mm and the alternate hypothesis H1 is mu not equal to 0.5 mm. So this is the null and the alternate hypothesis. So here we can see that this is a two-tailed t-test. So thus a two-tailed test is applied under hypothesis H0 and we have the test statistic T is equal to x bar minus mu upon s by root of n minus 1 or it is equal to x bar minus mu into n minus 1 upon s. Here we have x bar is 0.53, mu is 0.5, that is what we have taken as H0. Then n is 10, s is 0.03. Therefore, t is equal to 0.53 minus 0.5 upon s is 0.03 into root of n minus 1 into root of 10 minus 1. So this is equal to 0.03 upon 0.03 into root 9. So it is equal to 3. So we have got the t value as equal to 3. Here they have given the area in one tail. That is, they have given t 0.025. it is equal to 2.262. So if we draw the graph, this is minus 2.262 and this is 2.262 and this is the region of rejection. If our calculated value of t, if it lies in this interval, then we can accept H0. Otherwise, we have to reject H0. So here we got the calculated value of t as 3 and this 3 does not lie in this interval. It lies in the region of rejection. As a result, we have to reject H0. So let us write the step. Since t equal to 3 does not lie in the interval, minus t 0.025 to t 0.025 for 10 minus 1 equal to 9 degrees of freedom. That is minus 2.262 to 2.262. We reject H0. And so the result is, since we have to reject H0, so we have taken H0 as mu equal to 0.5 millimeter. Only when the mean thickness of washers is 0.5 millimeter, the machine is working properly. If it is not 0.5 millimeter, the machine is not working properly. We got the decision to reject H0. It means the result is the machine is not working in proper order. Hence, we conclude that the machine is not working properly. So, this is the result. Here, writing the null hypothesis and alternate hypothesis carries 1 mark. Then we have finding the test statistic t. Finding the value carries 1 mark and writing the conclusion carries 1 mark. Now, moving on to the next question. A person invested rupees 15,000 in a mutual fund and the value of investment at the time of redemption was rupees 25,000. If the compound annual growth rate for this investment is 8.88%, calculate the time period for which the amount was invested. So here a person has invested rupees 15,000 in a mutual fund and that is the initial value is rupees 15,000 and the value of investment at the time of redemption, the final value is rupees 25,000 and here they have given the compound annual growth rate, it is 8.88%. We need to calculate the time period for which the amount was invested. So this is from the unit Financial Mathematics and the topic is compound annual growth rate. So here we know that the compound annual growth rate, it is given by final value upon initial value the whole raised to 1 by n minus 1 into 100, where IV is the initial value of investment and FV is the final value of investment. So here all these are given. Compound annual growth rate is given, final value is given, initial value is given. We need to find n. Given initial value is rupees 15,000, final value is rupees 25,000 and the compound annual growth rate is 8.88% or it is 0.088. Now we need to find n. So let us take this as 1. So from 1 we have this is 0.0888. So this is the compound annual growth rate. This is equal to the final value is 25,000 upon the initial value of investment is 15,000. The whole raised to 1 by n minus 1. So from this we get 1.089. This is equal to 1.667 the whole raised to 1 by n. So you let us take log on both sides. Taking log 1.089 is equal to 1 by n log 1.667. So from this we have n is equal to log of 1.667 upon log of 1.089. So the log values are given here. Log 1.667 is 0.2219. So this is 0.2219 upon log 1.089 is 0.037. So this, when we simplify, we get this as 5.99. Therefore, n is approximately equal to 6 years. So here for writing the formula 1 mark, and then after that substituting the values and up to this step carries 1 mark, and the final answer 1 mark. Moving on to the next section, section C. 11th question, it carries 4 marks. S&D Chemicals produces 2 products, an alkaline solution and a base oil, that are sold as raw material to companies manufacturing soaps and detergents. On the basis of current inventory levels and estimated demand for the coming month, S&D's management has decided that combined production of alkaline solution and base oil must be at least 3,500 gallons. S&D Chemicals are also committed to supply 1,250 gallons of alkaline solution to one of its major customers. The alkaline solution and base oil requires respectively 2 hours and 1 hour of processing time per gallon. The total processing time available for the coming month is 6,000 hours. The production cost is Rs 200 per gallon for alkaline solution and Rs 300 per gallon for base oil. Formulate the above as a linear programming problem and solve it by graphical method to help S&D Chemicals determine the minimum production cost. So here it is given S&D Chemicals produces 2 products, alkaline solution and base oil, and then the various constraints that is required are given here, and the production cost is given. Production cost is Rs 200 per gallon for alkaline solution and Rs 300 per gallon for base oil. We need to help S&D Chemicals determine the minimum production cost. So our objective function is to minimize the total cost. So let the company produces X and Y gallons of alkaline solution and base oil respectively. And let C be the production cost. So what we have to do? We have to minimize this cost. So the objective function is minimize C is equal to 200x plus 300y. So because it is given production cost is 200 per gallon for alkaline solution and 300 per gallon for base oil. So we have to minimize this cost. And then we will see what are the constraints. Subject to the constraints, so the first constraint is, it is given, company has decided that combined production of alkaline solution and base oil must be at least 3,500 gallons. So X plus Y should be at least 3,500 gallons. Then the next constraint is S&D Chemicals are also committed to supply 1,250 gallons of alkaline solution to one of its major customers. So this X should be at least 1,250. And then the next constraint is the alkaline solution and base oil requires respectively 2 hours and 1 hour of processing time. The total processing time available is 6,000 hours. So the third constraint is 2x plus y less than or equal to 6000. And then we have the non-negative constraints x comma y greater than or equal to 0. So this is first, second and third constraint. So now we have formulated the given problem as a linear programming problem. Now we have to use graphical method or the corner point method to find the optimal solution. So let us draw the graph. A graph sheet will be given for this question. So let us draw each of these lines on the graph sheet. So first let us take the first equation, x plus y equal to 3500. So when x is 0, y is 3500, and when y is 0, x is 3500. So we can plot these 2 points on the graph, and when we join these 2 points with the help of a straight line, we will get this line. So this is 3500 comma 0 and this is 0 comma 3500. So this is the line represented by the first equation. And then the second equation is x greater than or equal to, the next inequality is x greater than or equal to 1250. So the line corresponding to x is equal to 1250. It is a straight line passing through 1250 and parallel to the y-axis. So this is the line x is equal to 1250. So this is the point 1250 comma 0. This is 3500 comma 0 and this is 0 comma 3500. And then we have the next inequality, 2x plus y less than or equal to 6000. So for this, let us write the equation. So when x is 0, y is 6000, and when y is 0, x is 3000. So we have to draw a line joining the points 0 comma 6000 and 3000 comma 0. So this is 0 comma 6000 and this is 3000 comma 0. So we can draw a line joining these 2 points. Now let us find the feasible region. Now x plus y greater than or equal to 3500. This is the third. It will be this part. And then x greater than or equal to 1250. The region corresponding to this inequality is this region. And then 2x plus y less than or equal to 6000. The region corresponding to this inequality is this region. So this is the feasible region. And these are the corner points of this feasible region. So this is P, this is Q, and let us mark this as R. Now we know that using the corner points method, the optimal value of the objective function will be reached at one of the corner points if the feasible region is bounded. So since this is a bounded feasible region, the minimum value of C will be obtained in one of these corner points. Now let us find the coordinates of each of these. The coordinate for P is, here Px coordinate is 1250. If we draw it on a graph sheet, then we will be able to get the coordinates directly. So the coordinate for P, it is 1250 and 2250. So this is the coordinates for P. Then the coordinates for Q is 1250 and 3500. And then coming to the coordinates for R, If you are able to get it directly from the graph sheet, it is better. Otherwise, we can solve equations 1 and 3. So if we solve equations 1 and 3, we will be able to get the coordinates for R. So if we solve x plus y equal to 3500 and 2x plus y equal to 6000, if we solve these two, we get x as 2500 and y as 1000. So the coordinates for R is 2500, 1000. So these are the various corner points and the coordinates for each of the corner points. Now let us draw the table. So we have the corner points and the objective function C is equal to 200x plus 300y. So the first corner point is P with coordinates 1250 and 2250. The second corner point is Q with 1250 and 3500. And then the next corner point is R, 2500 and 1000. Now for this corner point P, the objective function C is 200 into 1250 plus 300 into 2250. So it is equal to 9,25,000. The next one, 200 into 1250 plus 300 into 3500. It is 13 lakhs. Then for next one, when x is 2500 and y is 1000, we have the cost as 200 into 2500 plus 300 into 1000. This is 8 lakhs. So this is minimum. So here we can see that the minimum cost is rupees 8 lakhs when 2500 gallons of alkaline solution and 1000 gallons of base oil are manufactured. So here in this question, formulating the given linear programming problem, it carries 1.5 marks. Then drawing the graph carries 1.5 marks. All these workings, it can be shown in the rough. We need not show it in the fair side. So this carries 1.5 marks. The graph carries 1.5 marks. And then finding the corner points and writing the result, it carries 1 mark. So a total of 4 marks. Now moving on to the next question. A machine costing rupees 50,000 is to be replaced at the end of 10 years when it will have salvage value of rupees 5,000. In order to provide money at that time for a machine costing the same amount, a sinking fund is set up. If equal payments are placed in the fund at the end of each quarter and the fund earns 8% compounded quarterly, then what should each payment be? So here this is the sinking fund problem. Here a machine costing 50,000 rupees, it should be replaced at the end of 10 years and the machine has a salvage value of rupees 5,000. In order to provide the money, a sinking fund is set up, and here equal payments are placed in the fund at the end of each quarter and the fund earns 8% compounded and quarterly. We need to find the amount of each payment. What should each payment be? So the amount of sinking fund S at any time, it is given by S is equal to R into 1 plus I the whole raised to n minus 1 upon I. So here R is the periodic payment, I is the interest per period and n is the number of payments. So here we have S's, it is the cost of the machine minus the salvage value. So the cost of the machine is 50,000, salvage value is 5,000. So S is equal to 50,000 minus 5,000. So this is equal to 45,000. And then I is, here it is given 8% compounded quarterly. So I is 8% is 0.08 divided by 4. It is 0.02. Now we need to find R. Let us take this as 1. So from 1 we have 45,000 is equal to, and N is equal to, here equal payments are placed at the end of each quarter. So the number of periods will be 4 into 10. So N is 4 into 10, which is 40. So the number of payments is 40. So from 1 we have 45,000 is equal to R into 1 plus 0.02 the whole raised to 40 minus 1 upon I, 0.02. So this is equal to 45,000 into 0.02, it is 900. This is equal to R into 1 plus 0.02 is 1.02. 1.02 the whole raised to 40 is given as 2.208. 2.208 minus 1. So 900 is equal to 1.208 into R. So from here we have R is equal to 900 upon 1.208. This is equal to 745.03. So each payment should be rupees 745.03. So writing the formula, it carries 1 mark, and then substituting all the values and then writing what is given, all these up to this carries 1.5 marks, and if up to final answer it carries 1.5 marks. Next question. A couple wishes to purchase a house for rupees 15 lakhs with a down payment of rupees 4 lakh. If they can amortize the balance at an interest rate 9% per annum, compounded monthly for 10 years, find the monthly installment. Also find the total interest paid. Given 1.0075 whole raised to minus 120 is 0.4079. So this is the loan amortization calculation of EMI. Here a couple wishes to purchase a house for rupees 15 lakhs. So this is the cost of the house, and down payment they are giving rupees 4 lakhs. And then they are going to amortize the balance at an interest rate of 9% per annum. This is compounded monthly for a period of 10 years. We need to find the monthly installment. So here the amortized amount is P is equal to cost of the house minus cash down payment. So cost of the house is 15 lakhs and down payment is 4 lakhs. So this is equal to 11 lakhs. So we have I is 9% per annum, but I is the interest rate per period. So it is 0.09 divided by 12. So the interest per period is 0.0075. And then the number of payments is, they are paying monthly. It is every month installment. So N is 12 into 10, which is 120. Now the EMI is given by R is equal to P upon present value of annuity for n I. So this is equal to P into I by 1 minus 1 plus I the whole raised to minus n. So if we substitute each of the values, we will get the answer. P is 11 lakhs, I is 0.0075 upon 1 minus 1 plus 0.0075 the whole raised to minus n is 120. So this is equal to 11 lakh into 0.0075, it is 8,250 upon 1 minus 1 plus 0.0075 is 1.0075. So 1.0075 the whole raised to minus 120 is 0.4079. 0.4079. So this is equal to 8,250 upon 0.5291. 5921. This is equal to 13,933.5. So we have EMI equal to rupees 13,933.5. It is also asked, also find the total interest paid. So total interest paid if we see EMI, it will repay both interest and principal. So we can find the interest component alone by multiplying the EMI with the number of periods and subtracting the principal amount. So it is equal to R into N minus P. So this is equal to 13,933.5 into 120 minus 11 lakhs. So this, when we simplify, we get it as rupees 5,72,020. So the total interest which is paid is 5,72,020 for the amount borrowed 11 lakhs. So here writing the formula carries 1 mark. Then finding the amortized amount carries 1 mark. And then finding the EMI value carries 1 mark, and finding the total interest paid carries 1 mark. Now this question has an internal choice. It says a rupees 2,000 8% bond is redeemable at the end of 10 years at rupees 105. Find the purchase price to yield 10% effective rate. So here the face value of the bond is rupees 2,000 and the nominal rate is 8%. It is redeemable at the end of 10 years at rupees 105. So the redemption price is, it is not redeemed at par, it is redeemed at rupees 105. So the redemption price will be different. We need to find the purchase price to yield 10% effective rate. So the yield is given as 10%. We need to find the purchase price. So the face value of bond F is given as rupees 2,000. Then the redemption value will be, it will be 105% of the face value. So the redemption value C is equal to 1.05 into 2,000. So it will be rupees 2,100. If the bond is redeemable at par, then these two values will be equal. But here it is given it is redeemable at rupees 105. It means it will be redeemable at 105% of the face value. So it is 2,100. And the nominal rate is given as 8%. So ID is 8%. So the periodic dividend payment R, it is given by F into ID, the face value into the nominal rate. 8% is 0.08. So it is 2000 into 0.08. So this is rupees 160. And then the number of periods before redemption, N, it is 10 years. Here it is given, it is 10 years. So N is equal to 10. And the annual yield rate, it is given as 10%. So I is 10%. This is 0.1. So the purchase price given by V is equal to R into 1 minus 1 plus I the whole raised to minus N upon I plus C into 1 plus I the whole raised to minus N. So this is the present value annuity factor and this is the present value of C. So if we substitute each of these, we will be able to get the answer. R is 160, 1 minus 1 plus 0.1, the whole raised to minus 10 upon 0.1 plus C is 2100 into 1 plus 0.1 the whole raised to minus 10. So this is equal to 160 into 1 minus 1.1 the whole raised to minus 10 upon 0.1 plus 2100 into 1.1 the whole raised to minus 10. 1.1 the whole raised to minus 10 is given as 0.3855. So this is 160 into 1 minus 0.3855 upon 0.1 plus 2100 into 0.3855. So here 1 minus 0.3855 is, it is 0.6145. So 0.6145 upon 0.1, it is 6.145 plus 2100 into 0.3855 is 809.6. So this when we simplify, we get it as 1792. So the purchase price V is rupees 1792. Purchase price is equal to rupees 1792. So writing all these, it carries 1.5 marks, and then substituting the values up to this carries 1.5 marks, and the final answer carries 1 mark. The next question, case study question. General anesthesia is used for major operations to cure the patients and conduct pain-free surgeries. Propofol is a commonly used anesthetic injected for major operations such as knee replacement or open heart surgery. It also acts as a sedative and an analgesic. So this is the information which is given about this drug propofol. A patient is rushed to operation theatre for a 2-hour cardiac surgery. A person is anesthetized when its bloodstream contains at least 3 mg of propofol per kg of body weight. The rate of change of propofol X in the body is proportional to the quantity of propofol present at that time. Based on the above information, answer the following questions. First subdivision, show that propofol given intravenously is eliminated exponentially from the patient's bloodstream. Second subdivision, what dose of propofol should be injected to induce unconsciousness in a 50 years, I think it must be 50 kg adult. 50 kg adult for a 2 hours operation. Given, so these are given 2 raised to 1 by 5 the value is given, and half-life of propofol is 5 hours. So these information are given. So this is from unit 3 calculus under differential equations. This is under one of the growth and decay models, which is drug assimilation model. So here it says a person is anesthetized when the bloodstream contains at least 3 mg of propofol per kg of body weight, and it is given rate of change of propofol X is proportional to the quantity of propofol present at that time. Now we need to show that this propofol is eliminated exponentially from the patient's bloodstream if it is given intravenously, and we need to find what dose of propofol should be injected to induce unconsciousness in a 50 kg adult for a 2 hours operation. And it is also given half-life of propofol is 5 hours. So let us solve this step by step. Given dx by dt is proportional to x. The rate of change of propofol is proportional to the quantity of propofol present at that time. So dx by dt is proportional to x. Now since this is a decay model, we have dx by dt is equal to minus k into x. So this implies dx by x is equal to minus k dt. Now integrating both sides. Integral dx by x equal to integral minus k dt. So this implies log x is equal to minus kt plus c, or we have x is equal to e raised to minus kt plus c, or x is equal to e raised to minus kt into e raised to c. This we can write it as lambda into e raised to minus kt, where lambda is e raised to c. So let us take, let x equal to x naught at t equal to 0. So this implies x naught is equal to lambda into e raised to 0, or lambda equal to x naught. Therefore, x is equal to x naught into e raised to minus kt. So this is the model. So this is the first subdivision. Show that propofol given intravenously is eliminated exponentially from the patient's bloodstream. So the propofol which is given intravenously, it is eliminated exponentially from the patient's bloodstream. So this is the first subdivision. Now moving on to the second subdivision, B. First let us write the model here. X is equal to x naught into e raised to minus kt. Here it is given half-life of propofol is 5 hours. Half-life of propofol is 5 hours means when t is equal to 5, x will be x naught by 2. Since half-life equal to 5 hours, we have x naught by 2 equal to x naught into e raised to minus 5k. So from this we have e raised to 5k equal to 2, or e raised to k equal to 2 raised to 1 by 5. Let us mark this as 2 and keep. Now the quantity of propofol needed in a 50 kg adult after 2 hours. So here the patient should be unconscious for 2 hours. So after 2 hours, the quantity of propofol which is needed in a 50 kg adult will be 3 into 50, because for every kg of body weight 3 mg of propofol is needed. So the quantity of propofol needed in a 50 kg adult after 2 hours will be 3 into 50 mg, which is 150 mg. So from 1 we have 150 equal to x naught into e raised to minus 2k. Because the operation is for 2 hours, so time is 2 and the quantity required is 150 mg. We need to find the initial dose that has to be given to the patient. X naught we need to find. So this implies x naught is equal to 150 into e raised to 2k. It is 150 into e raised to k the whole square. It is 150 into e raised to k is 2 raised to 1 by 5. This is from 2. So in the question it is given 2 raised to 1 by 5 is 1.1487. So this is equal to 150 into 1.1487 the whole square. So this when we simplify, we get it as 150 into 1.3195, which is 197.93. So the amount of propofol which should be injected to induce unconsciousness for a 2 hours operation in an adult whose weight is 50 kg. It is 197.93. Therefore, required dose is equal to 197.93 mg. So here up to this step carries 1 mark, then finding the model carries 1 mark, then finding e raised to k it carries 1 mark and the final answer carries 1 mark. I hope this video was useful for you. In the sample paper, most of the questions are from the example questions or exercise questions in the student support material. So please be familiar with the example questions and exercise questions and practice the exercise questions as well. All the best for your exams. I hope this video was useful for you. Thank you for watching.